How you doing, guys? My name is Ace, and I've decided to try to solve connect4 for two players only using TypeScript type system, meaning there will be zero code that will compile to JavaScript, which means this code is completely useless. Okay, so I've already started the initial part of defining everything, but just to give perspective of how the game works, you have the game, like you can connect four of the same ones. You have the first player, which is white, the second player, which is black, and you don't have anything in this position, which is brown. So you can connect four in with a row or with a column or diagonally. So that's what I'm trying to solve for this specific part, but we'll get to how I eventually solve it, and also what will be the input. Let's talk about what will be the input. The input for how to play this game will be a string which correspond to each column, meaning that let's just say that this is the first. Let's just go. Like, there will be 1, 2, 3, 4, 5, 6, 7. You can put any number between 1 to 7, and that will be like what we're trying to solve. Also, the next thing, and the thing that we didn't do with the tic-tac-toe, is we're actually doing a more dynamic algorithm to change what's within the array. Never mind. Don't really care about that. Let's begin. So I have the player union, I have the placement union, I have the row type, and I also need to create a bunch of addition and subtraction in order to solve for this connect4. So what I'm going to do is I need to have type. Well, I have the row type. I need to have a row union. So it'll be a row union. The row union is any number 1, 2, 3, 4, 5, 6, any number between those, and I have a column union, which is this guy. So I have a column union, which is almost the same except I have a 0. I have a turn union, type turn union, which is pretty much all of this. And I just need to add 7 in the end. So this will be I will use this to convert. I'll use this to convert the column to union. Also, I'm sorry, I'm quite nasally. Hopefully that will be fine. And what I'll try to do is the turn union is essentially a string. So I'll do this, and I'll create. No, like I can do it later. Okay. Now first, we need to define what will be the method of how you placing something within the board. So I need to, before I'm going to do that, I need to define how I'm going to change the array after deciding on a row. So we type new array, new row should have board, which is board type, and I also have the row because I know which row, or would I say I don't know which row, but I just know the column, or just to say new row array. Okay, so it'll be, I know the column and I know the player. So player will be extents of player union. And also I need to know the column, which the column is part of the columns union. Column union. Okay. So now, the way I'm going to do this, I'm going to create a new array that corresponds to the previous array. So for that, instead of writing the board type, man, I'm so nasally, god damn. Okay, instead of writing the board type, I'm going to write the row, which extends a row type. And then I'm going to create the new array in the left side. New array new row, which extends a placement union array, which is an empty array. And I will return this new array after I'm done with this function. So let me just change it for a bit. So how am I going to fix that? I need to change it recursively. So I'm going to ask if the new array in its length extends, well, we can say both the row and the row length, or 7. I'll prefer to go 7 because it will solve me a problem in the future. Oh, you know what? Let's just write here row, and I'll just write here length, and I'll say, well, this line caused a problem. Length will cause problem, and we'll see that in the future. Okay, so if the new array extend the row array, meaning there's the same length, then I need to return the new row array. Oh my god, that'll be so hard to say. New array, new row. Oh, that is also very confusing. Maybe I should change it. I'll change it in the future. So it's the new row. Else, I want to ask if the new row's length extend the column, because column is one of the possible positions for this array. So if it does, meaning that I've reached the placement where I should have placed the nuclear, then I need to continue with the function of the new row array. My god, new row array. And I'll just write here row, and I'll write here the player, I'll write here the column, and I will concat, I'll just spread the new array, new row, add to it the player, and just continue on calling the function. But for all the other cases, I will just add whatever is the element's length is, meaning that the new row is the row, I want whatever is in the row, in the new row length. So that might seem a bit confusing, but this is the simplest way to solve for changing something within the array, or this is the simple way that I found. So I'll give you an example. So type check new row array equals to new row array, and I need to write here I can have the placement unit. I can write the initial row. I can write initial board. Just write initial board. Initial board at, let's just say 1. Doesn't really matter. So this is the row, and I have the player, which is, let's just say that's the first player, and I want it at the third or fourth, and that's pretty much it. And what we'll see is that it changed the array at the third position index space 0. Okay. Now, after we calculated a new row array, I need still to change the board. So type board, I'll just say new board, equals to, well, it should have a board type. Board extends board type. I would also like to know the player extends player union. I would also would like to know the row, which extends the row union. I would like to have the column, which extends the column union. And if I need to create a new board, that's all the information that I need to create a new board. Now, index-based creation. How did I say that? I have a new object that is almost identical to board, except that it has slight changes. Prop in key off board. Then I would like to add also text, because text will become an option in the future. And I would also like to get rid of that as well. So for text. Then I'm going to say, and I'm going to ask myself whether or not board, no, just say prop. Prop extends text. Then if it does extend text, then I want to return empty, because it really doesn't matter. If it doesn't, then I want to ask whether or not prop equals to row, right? Yeah. If it's the extends row, it exists. If it doesn't extend row, I just need to have board at prop. Right? No, that is not true, because I need to drop the piece from the highest to the lowest. But you know what? Let's just give this calculation to something else, and I'll try to solve for the physics of this board later. So how would I do that? So I can use subtract, or I can use sort of inference to figure it out. Well, you know what? Let's just try to position the player and then talk about how I'm going to fix it. So if the prop extends the row, meaning it's the place where we should change something, then I want to say that it should be the new row array at board at prop, which is the row, and I want to have the player, and I want to have it at column. Okay, it seems to be mad at player because placement union. No, player union. Player union. Okay, cool. Now to test for this new board, so I'll type check new board equals to new board with initial board with the first player at row, I just say row number 2, and with the column, I just say column number 3. I need to see it. Cool. So it's 2, and since it's base 0, it's straight in the middle. Now I would really like the new board to also do the calculation for whatever. Well, this is a big row. So I need the board to also do the calculation for whether or not the piece is in its rightful place. So I can do this in the new board method, and I'll just sort of fiddle with it. It should definitely not have a row union, but it should have a column union, and the row union should be the default of 1, and it will go down. So I have a subtraction method. I have an addition method for row. So I'll explain what I'm doing. So row extends. I'll just move the variable because I want to add a default. Row union, which equals to 1, which is the first thing that needs to change. And then I need to ask whether or not this place that column and row inside board is a player. If it is a player, or with the subtraction of 1, if it is a player, then I want to place the new player at this current location. So essentially developing the physics part of this connect4. So the way I'm going to do it is something like that. I need to first have a subtraction method for the row. So type subtract row is equal to an array that, well, let's just say we have to have row which extends row union. And since there isn't any 0, so it should be never. Since it has a 1, it should never have a 0 as a result. So now I can write 1, 2, 3, 4, 5, 5, and 6. Well, I don't have 6 as well because I'm subtracting, and this should be 0. So essentially, if you plug in 5, and then I'll count 0, 1, 2, 3, 4, 5. I've subtracted from the row just 1, or I just need to add. Oh, it's not subtract; it's just to add. Add 2 row, and it should have the other way around. It doesn't have a 0, but if it reaches to 1, then it should have 2, and if it's 5, it's 5, and it's 6, it's 6, and if it's 6, it's never, because it can never reach to 7. So even though it seems kind of weird that I have 2 nevers, I have here 4, and here I have 5, and in here I have 6. It's absolutely fine because I'm not going to count for the first row because I'll have a separate check for that one as well. So I need to ask myself. This is let's just right here. This is for creating the new board. But I don't want to create the new board until I've officially decided whether or not the current row with the column extends for the board itself. So if it's a player or not a player. So I'm going to ask if board at subtract row, subtract. I know how to write subtract, right? No, oh, it's add to row, not adding. I'm adding to row. Add to row, and then I write here row, and then column. So notice I'm just starting at the second phase because the first layer will be, I have a separate check for it. So I wanted to ask if it extends the player union. If it does, then I want to deal with the entire creation using this row, meaning that if 2 has a player, if like this one is the first player, then it will add the player that I have currently here. It will have the new player to here, to the column above it. So that's a neat trick. But you can, and if it doesn't, then I need to say, okay, I wanted to call the new board. So I'm going to say new board with board and player and column, because the column doesn't change in this game, and add to row. And what that it will do, that it will go down. But there is also another case where I don't need I need to stop. Like if I reach the 6th floor, meaning that the column is never. So this is an OR condition, which you cannot simply do. So it should be if this or this. Okay, so if it's board extends player union, or I can have it if board, just right here, add to row. If add to row as a tuple, I'm going to explain what I'm going to do it. Add to row. I need to ask myself if it's never, and I have placement union. So it should be placement union. Or I have here a number, which it is, and I have a player union. So this is an OR condition to have the ability to OR condition within the type system of TypeScript. I'm just putting them tuple, and then I'll just search for each one individually. And what that'll happen is I realize that I don't need now the row, and it just should continue to drop down till it reach the end. So that's cool. So I'll also have initial board if board or text, if prop extends text. If it does, then it does, and if it doesn't, well, but initial board doesn't have text. It's fine. We'll figure that one out later. Okay, so it drops, but does it follow the rules we've suggested? So the way to test if it follows, like it uses the physics. So I'll take whatever the check new board returned, and I'll check it with checkboard 2, and I'll add the second player onto the same row, and what we should see, it just stack them together. So that's cool. That's exactly what we wanted. Next. Okay. After we are done with this, so now we have the sort of physics that the board has. And now we need to figure out whether or not the game finished and who is the winner. So this is the board logic. I'm going to write here. This is the board logic with, let's just say, board logic. Okay, and now I'm going to write here tie or draw logic. The way to do it is pretty much straightforward. I'll have a new type named tie. It will be a board which extends the board, and I'm gonna scan through all the board with the row and the column, and I'll just try to figure out whether or not if it works. So I write here row, which extends row union. But since we're starting from above, we'll do it from, we have the row. So we also need to add an add method for the, okay, that's fine. I need to scan through each row in this matrix. I need to scan through all the cells in this matrix. So what I'm going to do, in order to do that, I need to call it recursively, which means it equals to 1. And I'll start from this, so it's 1, 0. And I'll keep adding 0 to the column until I've reached never. Because adding 1 to the same thing over and over again until I reach never, it should just figure out if it works or not. So if I reach never with both of them, with the row and the column, then I've done scanning this entire matrix, and then I can declare true. So that's the first useful thing to keep in mind. So column should extend column union, and that one should be 0. So now I need to also create an add method to the column. So I have a column union. So I'll do add, it'll be almost identical. Add to column, and it should change the word column, and to a column union. Fine. And it shouldn't be column, column. And this time, the column union is 0, 1, 2, 3, 4, 5, 6. If I'm trying to add 1, 0 should have 1, and that's it. And that's it, because you can add to 6 more. So now comes the fun part. I need to first say, well, is row extends never? Because if it does, then I'm done, right? If row and column extends never, then I'm done. If row extends never and column extends never, then I'm done. Then I'll try to say true. The worst case scenario that I have here is you do have the column, but you definitely don't have it, like, okay. Then you don't have the column, but you do have the row. That means that I need to call for tie with an added row and the column at 0. So board will be equal to, well, and there is a way to check it. So if the column is never, then I cannot scan the cells. So it's fine. Board row, add to row, row, and I'll reset column to 0. And if I have both the row and the column, then I need to test if the board at row and at column extends blank. Because if it does, then I need to call it false, because it's incorrect. However, if it is true, and if like this case does work for itself, so let's just say if it does, then I can just call tie again on board with the same row but an added column. The column. Okay. Now, in order to test it, I'll just go and write check tie. it'll be like the first one. So type for initial board should obviously return false. For the row and the column, it's fine, those are not mandatory. This is false. Now, if I were to change this entire board to all first, the way to do it will be to just copy this entire thing and change within it to first player. But I don't feel like doing it. I feel pretty confident about this code. So I'm not going to test for it, but generally I would test for it, but just like it's a waste of time. Next, that's the tie logic. Because we keep adding, like, it's obviously going to work. Next, I wanted to have the winning logic. Now, winning logic is slightly more complex than the time logic, but it follows because it follows the rules of I need to scan only 4 from which side, and since I'm not really keen on making things more efficient, I will just write it as brute force as I can. I'll have it for the row, for the column, for the left and right diagonal differently, separately. So I'll have here 4 types. So type, winning by row. If you're winning by row, that means that the board extends board type. I don't really care. They follow the same logic. So row extends row union, that is equal to 1. Column extends column union, HUR 0. And then it follows almost the same rules, but it has a limit, which is the count that I'm going to do. And I'm going to extend an unknown array, which should be empty. Okay. Now, in order to win by row, that means that from where my row and my column is, I need to change moving only by the row. So if I need them, if winning by row is not like a scan, full-on scan, then I need the row and I need the column. But since I'm scanning by row, the only thing I need to do is to add to the column and to see if I'm getting to never or not. Because if I am, I'm not winning here. So, board, let me just go back. Board, if count at length, just imagine I can write length, extends 4, then if it does, then I know who is the winner. So I have a winner. And I also need to have a player to know from which player I'm comparing it to. So player should extend player. Okay. If count length extends 4, then it does. However, there are the off cases, which means row cannot be never with this case. And I'm not going to even, you know what I can do. If row extends never, row can never extend never like this. Also, that's a thing. That's a thing that I just remember. Never, you cannot extend never to anything. You have to put it within an array, and then it will figure it out. It's something about TypeScript. It does it. It's the way it's supposed to behave, but it's really weird. So that's how you extend, and that's how you know if everything is never. So never. If row extends never, then, well, I don't know what you're doing, so there is no winner. So, and if column extends never, then that's definitely false. So you could ask yourself, why am I not doing like a more or union like? Well, for this it's too complex for me to care enough, and also never doing an array of never that extends or column or row. It's slightly more tedious, and it didn't work the last time I tried to do it. So I'm not caring for this too much. So, and then I'll ask, does board at row at column extends player? because if it does extends player, and I want to call winning by row for the board, the player, the same row, but add to column. And also I would like to add to the count just 0. Now, if it might look weird, the thing that I'm doing about counting, you shouldn't be I'm just keep adding to an array. And eventually somewhere around the future, the count should be positive or negative. Like it should be something. It will be something somewhere along the future. And count will be equal to 4. Worst case scenario, and if it doesn't, it's false. Now, there are many other ways to solve it that doesn't look like shit, but it's fine for now. It's just like we're trying to test for the logic that it works on the most basic level. So I'll have here type winning by row. So winning check winning by row equals to winning by row, and I'll have to generate some new thing to make sure this one it works. And I want it for the first player, and I want it for the first row because this one is by the row. And I also like start with the 6th row at the 0th column, and I'll have this entire thing, and I'll just slightly modify this thing to look better. So it should be here. Should be first player. Now this one is still false. And when I add first player here, then it should be true. Awesome, it works. So now I can move to the column logic. Both are not that different, at all. So the only thing that happens here is that instead of adding to the row, instead of adding to the column, I'm adding to the row. And the same logic applies here. So if winning by column, and also I need to be very careful that I'm calling the same recursive function, otherwise it will not work. Instead of adding to the column, I'm adding to the row, and it's from here on it's a smooth sailing. Add to row. Okay. And have winning by column. I can take the same thing. Again, be mindful about the names. So by column, win by column. No, win in not check. Okay. And then instead of this, I'll have, if you want to win by column, then you start from the 3rd, 4th, 5th. So you have 3. And I need to have, this is obviously false, and I have to have first player in here, and here, and in here. And I'll just clean this thing. And now it should be true. Cool. So now it works for both winning the row and winning by the column. Now, there is a diagonal that is simpler, and there is one that is more complex. But it's still the same thing, because once you solved for one, you're going to solve for all of them. Really, it's not that complex. So I'm gonna copy all of that beauty, and I'm gonna put it in the end instead of writing. Wait, did it write winning logic twice? No. Winning by, and I'll say right diagonal because it's a simpler one. Okay. And be mindful about the recursive names. And I'll say winning by right diagonal, winning by word right diagonal. Okay. And then the same thing applies. Instead of this, I need to add both to the row and to the column to make sure that nothing iffy is going in. Add to column. Okay, now you start from the 0. This right diagonal should be false. Cool. Now I have if right diagonal from 3 to 0, it should be here and it should be here. So bye-bye and bye-bye. So now right diagonal turns false. Wait, did I miss one? I did miss one. It should not be there. It should have been there. Now it returns true. Cool. Now left diagonal is slightly stranger because you need to go left instead of right. Now to go left, you need to subtract, not add to column, but subtract from column. So add to column, it's pretty much the same thing, but instead of add to column, subtract from column. Column, column union, and I have here, if I want to sort of column union start with 6, and I should have subtraction, so 0, 1, no. If I have here subtract, never. Column, column union, okay. 0 does not have anything to contribute. 0, 1, 2, 3, 4, 6, okay. So 0, 0 to 0. Should have here 1, place to 0. And I definitely can have here 6 because the 6 is the highest number. So I plug in 6. It should be 0, 1, 2, 3, 4, 5, 6, and it's fine. Cool. So the same thing, almost the same thing, without the winning logic. Just copy and paste. Be mindful about copying. Winning by left diagonal. Winning by left diagonal. And instead of adding to the column, we're going to subtract from column. Subtract. So winning left diagonal should be B. P left diagonal. This obviously should be false. And this I'm going to need to start from sort of the middle. So it'll be, let's just say 1, 2, 3, 4. I'll start at the third row. So the third column. Replace with 3. I'll start from the third row. And then I have everything pretty much worked out. So I have here 0, 1, 2, 3. Okay, 0, 1, 2. And I have here this guy. Yeah, I need this guy instead of this guy. And this guy instead of this guy. And I need to add here a comma. So you start at 0, 1, 2, 3. Then you lower yourself to here. Then it goes to here, then it goes to here. So that should be true. Amazing. So are we done with most of the logic? Yes, we are. However, I definitely did not add to board with text. I did sort of do that. Let's just say, oh, it should not be question mark for text because it might contain text. And now it doesn't show text. Okay, bad. So now I need to also have the ability to add to the text to have messages shown to the user, which I sort of forgot to do. So let's just add it forward. In order to generate a new object with the same text, it's pretty straightforward. You need to do pretty much what we did here. And I'm going to call the type board with text, which just get board extends board type. And equals to What did I change here? I didn't change anything here, just added a space. But instead of doing all of that, I'm gonna add here or text. And I also need to have another variable named text in this. So text extends string. And if prop extends text, then it should be text. Otherwise, it could just be board using prop. Cool. And now I've added board with text. The simplest way to test it is just to make sure that, I can add check. Type check board with text, which equals to board with text, which accepts initial board and some message. And this one is pretty straightforward. Cool. Now, does that mean that we were clear? Now comes the fun part, because we have each individually. However, we need to have them all within one big winning function. So type winner equals to, which should extends board type, and I can have here row, which extends row union, which equals to 1, and column, which extends column union, which equals to 0. And now I'm going to do it the most disgusting brute force way to figure out if a player won or didn't win in this case. So, is anyone winning by row for the board? In the row, in the row, in the column. If it extends true, or true as a smaller thing, for the whatever player is. So instead of that, first I need to check whether or not board at row at column extends player. I can say blank and then return false. But I don't need to, no, I'll do player and then I'll think about it. If it extends player union, then I need to ask myself, where is board at row at column and does it extend true? If it does, then I need to return the board at row at column. And these two lines will have to be copied and pasted around 4 times. And I also can have it in a one big ol' union. But now I just want to make it simpler. Winning by row, winning by column, winning by right diagonal, winning by left diagonal. Now, if we don't have a winner, it doesn't mean that we should give up. It means that we should try again. Unless row and column reach their nether. So all of this is with the check that does row, if row extends never and column extends never, then I need to return false. In the other case, I need to call winner with the moved thing. So for me, it will be, if I don't have column, then I need to add to the row and reinitialize the column. It's the same that I did there or somewhere else. And the same that I always do. So I have here for, oh, it was for tie. It was when I scanned with using tie. So I have here board, and I have here add to row, and I'll have here row, and I have here column, which I will reinitialize to 0. If that's what happens if column and row is both uninitialized or initialized properly. Now, if it does all fault for player union, that is good. If it doesn't, I need to call winner for board, for row, and add to column. Yep. But I feel like if it does, and I have here another thing, what do I have here? Let's see. If it's winning by row, if it's not winning by row, if it's winning by row, if it doesn't extend player union. Oh, that's why I did that. Because if it doesn't, then I'll have to write the same function sort of twice. So that's why I did that. Okay. Well, then let's have a look at the code. So if row extends never, which, right here. If row extends never and column extends never, then it's false. And I didn't figure out the winner. If it does, if only the column is never, then I need to reinitialize column, add to the row 1, and do this entire process again. If the row and the column are both not never, then I need to ask if they are player of union. If they are player of union, did you win by row? Did you win by column? Did you win by right diagonal? Did you win by left diagonal? If you did not win by left diagonal, meaning that I need to add 1 to the column, or if the board at row at column doesn't extend player union, which might be blank, then in this case, I would like to retry winner with different parameters. And this time, winner does not accept row and column as mandatory, so I'm just gonna grab. I can have the initial board, I can have this. So let's just write it for here. Type check winner equals to winner. And I'll have here board. And instead of board, I'll have here all of this. Yep. Did I close it off? But the indentation is insane. Okay. Didn't work. Why did this scan didn't work? Okay, I'm back. Apparently the problem was the row is never, and if it is never, then there is no winner. But if the column is never, and it's the same algorithm I did it on the other way, which pissed me off. But it's fine. It's solvable. It's fine. It's fine. So now we have a winner. Ta-da! Okay. Are we done? Yes, because we have all of the logic that we need. Now, type connect4, just like any other turn-based game, is a recursive game. Board type extends board type, and connect4 should have anything. No, it should have a player, which is a player which extends the player union, which equals to the first player. And it should also have turns. So turns that extends string and definitely should equal to something. And now, with everything considered, now we are going to recursively call connect4 for all of these. So, how am I going to do this? First, I need to check. I need to separate the turns from the string. So, I need to say turns extends a template literal, which infer for turn, and the rest of turn, and infer. And if it doesn't, oh well, let's just say if it does, then I need to call this entire thing. If it doesn't, then I need to have board with, I need to return, let's just say I return the board. So for empty game, I'll have an empty solution. Now, for the other thing, if, well, I can write it here. Okay, I need to ask myself, does the turn extend? And I need to have it turn union. If it doesn't, I need to say board with text, board, invalid character. Only 1 till 7. And I write here, you know, actually I write it as a template literal, and I write here turn. Okay, and then if it does extend turn union. Oh, before all of that, I need to ask if there is a winner. Is it a draw? Board extends true. If it does, if it is a tie, well, I know I need to ask if there is a winner before if there is a tie. So winner for board extends player union. Then I want board with text, board. The winner is winner at board. As you can see, it's slightly, not slightly, very much inefficient to call winner for board twice, but inefficiency is not the main core of what I'm trying to solve here. So if we have a winner, what happens if we have a tie? Well, if we do have a tie, we need to the tie to extends true. If it does, board with text, board, and add tie. No winners. And then I need to ask myself, well, what about turns? Well, now I need to calculate for all the turns. If the turn extends turn union, and the turn is invalid, it might be invalid, or the board at the first row at convert, I'll say turn to, oh, I don't have it. So now I need to convert the turn to turn to a column. So do I have the turn union? Okay. I type turn to column, which equals to, if I have here, should be never 0, 1, 2, 3, 4, 4, 5, 6. And I have here at turn, and I'll also have here turn extends turn union. Don't ask me why TypeScript accepts strings to enter inside of arrays. That's not, I don't really care. Turn to column, at turn extends player union. Well, if you are trying to have it, I'll just say I'll leave it blank, and then just say I'll leave it blank, and then if it does extends for the player union, then I need to add for board with text, board, the column is already full. For let's just say I'll call it turn. Okay, and now if it extends blank, and I've checked for everything, now I need to call connect4 with the new board for the board and the player and the turn to column turn, and am I good here? No, I'm not good here. I should have here connect4, and I should alternate between the first player and the second player. So if player extends first player, then I want the second player, otherwise I want the first player. And I need to call for the new board and rest of turns. And now, as you can see, it's sort of mad here, and the explanation is very much not clear. Thank you, TypeScript. However, since I did this before, I know the problem, and it's not actually such a big problem. Like the code will still work. I've written here to do so will cause problems. Now, if new row extends 7, or 7 extends for the new row, or is the new row 7 lengths? Yeah, it is. Now there is no problem. Amazing. Why? Beats me. So type result connect4 for initial board and an empty string. So I can actually do it the other way around. I'll just have it here to be equals to initial board, and here I just have turns, which extends string, and oh my god, it returned. The problem has returned. Why did the problem has returned? Oh my god, that's a new problem. Is not assignable. Something is not assignable to string. Well, beats me, but it worked, so that is very much dumb. Okay, it works, sort of. Wow, that is crazy. So if I have here, the result will be an empty board. If I write here 3, because it's the third, and I write here 4, and I'll write here 3, and I write here 4, and I write 3, 4, 3. The winner is white, and for some reason it switched between the 2 and the 3. Amazing. Thank you, TypeScript. You're incredible. Really? Does it just it just switch between the 3 and the 2? Okay. Well, this problem is because TypeScript is stupid. Or maybe I switch between the row union, the column union, between the 1 and the 3, but I definitely didn't. So that makes it very stupid. 1, 2, 3, 4, 5. Yeah, you're stupid. But thanks a lot for TypeScript. The problem is technically solved, even though not in the beautifulest manner. And yeah, that's pretty much it. And I hope you guys enjoyed. This game takes a while. And if you wanna, oh, now it works. Fine by me. Fine by me, TypeScript. You do you. You know what? You do you, TypeScript. So now if I add here 3, and it did it again. Okay, lovely. So I'm not gonna. I don't know why TypeScript ended like this, but it does work. And the funny thing is, if I were to do 4, 4, 4, 4, 4, 4, 4, it's the column is already filled. You cannot do that. And also, if I were to try to add an A, it's invalid. And if I have a tie, which I'm not gonna do, it works. It works. Thank you so much, guys, for watching. I hope you enjoyed. I'm gonna, hopefully, if you guys like it, I'm gonna bring up more content. The next game should be Reverse, which is a very challenging game. And thank you. Hope you guys enjoy. Peace.